Here are the travel times in minutes of 15 workers in North Carolina, chosen at random by the Census Bureau. We aren't surprised to see that they're in increments of 5 for the most part, since people will estimate to 5 minutes. If you look, the distribution is single peaked and right skewed, and the longest travel time of 60 minutes may be an outlier. Our goal in this section is to describe the center and spread of this and other distributions of quantitative data with numbers. Our first measuring center that we're going to be talking about is the mean. X bar is our symbol for the mean. And we all know how to find the mean. We add up all the values and divide by the number of variables. So in this case, we'd add up all the individuals and divide by the number of individuals. This symbol here is sigma, and it stands for addition, to add them all up, or the sum of. The X sub I means all the individuals. This symbol is mu, and mu is also the average, or the mean, where X bar is the mean of the sample, mu is the mean of the population. If we could find the mean of the population by adding up all of the individuals in the population and dividing by the total number. Okay, so the difference between X bar and mu is X bar is the mean of the sample, and that's the formula, and mu is the mean of the population. If I found the mean of the workers in our problem, it would be 22.5. But if I calculated the mean, this time leaving out the person who reported the 60-minute time to get to work, it's 2.7 minutes less. So that 60-minute, one observation raised the mean 2.7 minutes. This illustrates a weakness of the mean as a measure of center. The mean is sensitive to the influence of extreme observations. In this case, that 60 minutes may be an outlier, but in a skewed distribution with no outliers, we'll still pull the mean towards the long tail. Because the mean can't resist the influence of extreme observations, we say it is not a resistant measure of center. So what is a resistant measure? It's a measure, the measure of resistance is a measure that is influenced by outliers or skewness. Is the mean a resistant measure of center? No. It can't resist the influence of extreme observations. So it is not a resistant measure of center. So let's take a look at the median. The median is notated by a capital M, and it's the midpoint of the distribution, the number such that half the observations are smaller and half of them are larger. That's easy to find in small sets of data and pretty tedious in large sets. So let's take a look at our data. There are 15 individuals here. So the 8th individual would be our median. So there's 2, 4, 6, 7, 8. So our median would be 20. Okay, the mean is higher because it's pulled toward the right tail. The median is resistant. If the longest time were 600 minutes, the mean would increase to more than 58 minutes, but the median would not change. Therefore, the median is resistant. So how can we estimate the mean of a histogram or dot plot? Well, if you know the median and the graph is symmetric, the mean is approximately the same as the median. So if the distribution is symmetric, the mean and median will be close together. If the distribution is skewed toward the right, the mean will be pulled toward the right, and if it's skewed toward the left, the mean will be pulled toward the left. So looking at your median, if it's skewed to the right, you are going to go over towards the right for the mean, and just the opposite if it's skewed towards the left. The mean and median measure center in different ways, and both are useful. But how do we know which one to use? Many economic variables have distributions that are skewed to the right, like college tuition, house prices, incomes are all skewed to the right. Many economic variables have distributions that are skewed to the right. College tuition, home prices, and personal incomes are all right skewed. In Major League Baseball, for instance, most players earn a minimum salary, which was $400,000 in 2009, while a few earn more than $10 million. The median salary for Major League Baseball players in 2009 was $1.15 million, but the mean salary was $3.24 million. Several these superstars pull the mean up, but do not affect the median. Reports about incomes and other strongly skewed distributions usually give the median rather than the mean. But in a county that's about to impose a tax on the incomes of its residents, cares about the mean income, not the median. The tax revenue will be 1% of total income, and total income is the mean times the number of residents. So, how should we choose the measure of center? The best measure of central tendency, is dependent on the distribution of the data. If it's skewed to one side, the best measure is the median. If the distribution is symmetrical, the mean is the best measure of central tendency, and you will want to use standard deviation with the mean. We sort of compared and contrasted the meaning of mean and median already. Remember that if the distribution is symmetric, the mean and median are going to be approximately the same. If it were completely symmetric, then they would be the same. If it's skewed to the right, if the distribution is skewed to the right, then the mean is going to move to the right of the median. If the data is skewed to the left, then the mean is going to move to the left of the median. Now would be a good time to check your understanding. So stop, and I'll get back with you in a minute. Okay, based on the stem plot, would you expect the mean travel time to be less than or about the same or larger than the median, and why? Since the distribution is skewed to the right, we would expect the mean to be larger than the median. Use your calculator to find the mean travel time. Was your answer to question 1 correct? The mean is 31.25 minutes, which is bigger than the median of 22.5 minutes. Interpret your result from question 2 in context without using the words mean or average? Well, if we divide the travel time up evenly among 20 people, that is what we're doing when we find the mean, would be each would have a travel time of 31.25 minutes. So the mean is actually just what the number we would have if we divided it up evenly, or everybody got their fair share of that travel time. And would the mean or median be more appropriate summary of the center of this distribution of drive times? Justify your answer. In this case, since the distribution is skewed, the median is a better measure of center of this distribution. The measure of center alone can be misleading. The mean annual temperature of San Francisco, California is 57 degrees Fahrenheit, the same as in Springfield, Missouri. But the wardrobe or the clothes that you would need to live in these two cities are very different. That's because the daily temperatures vary a lot more in Springfield than they do in San Francisco. A useful numerical description of a distribution requires both a measure of center and a measure of spread. The simplest measure of variability is the range, and that's the difference between the largest and the smallest observation. So, what is the range? The range is the difference between the largest and the smallest observation. It is not a resistant measure of center, since the minimum and maximum values could be outliers. Quartiles are 4 equal groups into which a population can be divided according to the distribution of values of a particular variable. The first quartile, Q1, lies 1/4 of the way up the list. The second quartile is the median, which is halfway up the list. The third quartile, Q3, lies 3/4 of the way up the list. These quartiles mark out the middle half of the distribution. The interquartile range measures the range of the middle 50% of the data. So what is the interquartile range? The interquartile range measures the range of the middle 50% of the data. The IQR is a resistant measure of spread, since it ignores the smallest 25% and the largest 25% of the values in the distribution. We need to have a rule for finding the interquartiles. The first quartile, second quartile, third quartile. We're going to use the same method as we did for finding the median. Okay, so to find the quartiles, first find the median of the observations by arranging the observations in increasing order, finding the middle number. Then find the first quartile, or Q1, by finding the median of the lower half of the observations. Find the third quartile, Q3, by finding the median of the upper half of the observations. Okay, so here is the data for the amounts of fat grams in McDonald's beef sandwiches. Calculate and interpret the mean, median, spread, and IQR. Okay, so here's the stem plot of our data. We could take a look at that and find our median. So our median is, there's 15 pieces of data, so our median should be at number 8. 1, 2, 3, 4, 5, 6, 7, 8. So 26 should be the median. So the median is 26, and the mean, if we added up all these and divided by 15, we get 26.26, repeating, or approximately 26.3. To find the first quartile, we'll take our first top half, or in this case it would be the bottom half of the data, Q1 is 19, and it's found by taking the lower half of the data and finding the median of it. And Q1 is 39, and it's found by taking the upper half of the data and finding the median of it. The IQR interquartile range is found by taking Q3 and subtracting Q1, and so our IQR is 20. So what does that mean? Well, that means that the range of the middle 50% of the amounts of fat in McDonald's beef sandwiches is 20 grams. Remember that an outlier is an individual that falls outside the overall pattern. It's a departure. Okay, so how are we going to identify outliers? Well, in addition to serving as a measure of spread, the interquartile range is used as part of a rule of thumb for identifying outliers. Okay, so we have this rule. It's called the 1.5 times the IQR rule for outliers. You're going to call any observation an outlier if it falls more than 1.5 times the IQR above the third quartile or below the first quartile. Okay, so do we have any outliers? Well, we're going to use the rule 1.5 times our IQR, which was 20, and we get 30. So Q1 minus 1.5 times the IQR would give us a negative 11. And quartile 3, that should say Q3, the third quartile, plus 1.5 times IQR is 19 plus 30, which is 49. Since our smallest observation is greater than negative 11 and our biggest observation is less than 49, we do not have any outliers. Okay, fixed it. So once you figure out your IQR rule, the 1.5 times IQR rule for outliers, then you subtract that from the Q1 and add it to the Q3, and that will tell you anything above, anything less than the Q1 minus 1.5 IQR will be an outlier, and anything above Q3 plus 1.5 times IQR, that would be, anything greater than that would be an outlier. When you find outliers in your data, you need to try to find an explanation for them. Sometimes the explanation is just a simple typing error. Sometimes it could be just a silly response that somebody gave, or the device that you were measuring broke down. When outliers are real data, like the long travel times for New York workers, you should choose statistical methods that are not greatly affected by outliers. What is an important final step when you take when identifying outliers? Okay, one final thing. AP tip. You may be asked to determine whether a quantitative data set has outliers. Be prepared to state and use the rule for identifying outliers. Have fun doing your homework.